This is day 13 of Unit 9. I'd like you to start with this warm-up today, so pause the video and try the warm-up, and then play to check your answers. So number 1, determine if the following are a permutation or a combination. So let's take a look at those. So the first one, selecting 3 out of 9 toppings to put on a pizza. Well, the order that I select the toppings does not matter. So that is a combination. Letter B, selecting committee for math club with president, vice president, secretary, and treasurer. There we're picking offices, so the people are being chosen and arranged. So that's a permutation. The number of ways of lining up dogs waiting to be groomed. Okay, so hopefully you thought a little bit about that. If they're lined up, that means they're waiting in that specific order. So the order does matter. You can kind of think of it this way: Spot's first in line and Sparky's second. If I flip that around and put Sparky first and Spot second, then Sparky's going to be groomed first. So the order there does matter. They're lined up. So that's a permutation. D, selecting a sewing committee of 4 out of 50 members of a club. They're just on a committee. They're not being put into specific offices. Therefore, that's a combination. The order doesn't matter. Number 2, 5 out of 9 students are chosen for the starting lineup of the school basketball team. In how many different ways can the coach choose the starting lineup? So here, the starting lineup indicates that the order matters. The people are being put into specific positions. So that's a permutation. So that would be 9p5. So 9p5 is 9 factorial over 9 minus 5 factorial, which is 9 factorial over 4 factorial. The 4 factorials are going to factor out, and I'm going to be left with 9 times 8 times 7 times 6 times 5. And when I do that, 9 times 8 times 7 times 6 times 5 is 15,120. That's a comma there, 15,120. So then 3, this time the coach is just selecting 5 members of the team from 9 who try out. In how many ways can he select the team? So here, this is 9C5, because now we're just selecting 5 members. We're not putting them in a starting lineup. We're not putting them in a specific position. So I could just do 9C5 using the formula for combinations, or I could take my previous answer of 9P5 and I could divide that by 5 factorial. So 9P5 is 15,120. And if I divide that by 5 factorial, which 5 factorial is 120. So then when I divide 15,120 by 120, I get 126. So 126 is the answer for 3. Okay, so today, short lesson, but a couple things I want to talk about. So we've talked about some problems where repetition was allowed. Today we're going to look at some where we have repeating letters in words. So if you would take a look in your packet on page 13, problem number 4. So it says, how many distinct ways can the letters in the word mash be arranged? Well, that's just taking those 4 letters and arranging them. So I could either do 4p4 there, or I could do 4 factorial, or decision chart 4, 3, 2, 1. And when I do that, I'm getting 24. Okay. So that's what I do with A. Now B, how many distinct ways can the letters in the word sash be arranged? Okay, and it mentions there on the page, on page 13, that the reason we need to use the word distinct is because there's two S's. So if I, for a moment, I'm just going to call that first S S1. And I'll call the second S S2. So if I'm putting them in this order, I have S1A, S2H. Well, if I flip around the S's, now I have S2A, S1H, but the same word has been spelled. Okay, so I don't want to count that as two different words because it's the same word. It's just that in this case, I have the second S first. In this case, I have the first S first. So I have to do something different because of the repeating S's than I would with the first word, mash, because those letters were all different. So I just did 4 factorial and I was done. So this is very similar to yesterday's lesson when we picked groups with Al, Betty, and Carl. So we picked a group ABC. Well, if I was just putting them on a committee, then I counted that as one group. But if I was putting them as like president, vice president, secretary, that counted as 6 groups. And if you recall, that's because there's 3 factorial ways of arranging the letters A, B, and C once they've been chosen. So there's 6 ways of arranging. So if we cared about the positions, the order, then we said that was 6 groups. But if we didn't care about the positions, we just called that one group. So if you recall, what we did to go from permutations to combinations was we took the answer from the permutation and we divided by r factorial. Now, how's that related to this? Well, I don't want to say that SASH and SASH are 2 different words. Just like I didn't want to call this ABC 6 different groups. I only wanted to call it 1. So we divided by, in this case, 3 factorial, which was our R. So similarly with the words, I don't want to call SASH and SASH 2 groups. I only want to call it 1. So this, again, is going to involve dividing. So the first thing you're going to do is treat it like there are 4 different letters. So 4 factorial. Okay. So the total number of letters factorial. But then what we're going to divide it by is each of the letters that repeat and the number of times that they repeat. So the S's, there are 2 of them, which means there's 2 factorial ways of arranging those 2 S's. Okay, so we're going to divide 4 factorial, which we just said is 24. We're going to divide that by 2 times 1, which is 2. And when we do that, we're getting 12. So there are 12 distinct ways for us to arrange the letters in the word sash. Okay, so let's try C. So the word sash, again, 4 factorial is what I start with, but then I'm going to divide by the number of S's, which is 3 factorial. So I'm going to divide 24 by 6, and when I do that, I get 4. Okay, so anytime it says distinct ways, that's referring to the fact that there's repeated letters, and you don't want to count those repeated letters multiple times. You just want to count it once because it's the same word, whether we were using the first S or the second S to start. So that's how you deal with words with repeating letters. The number of letters in the whole word, factorial, divided by the repeating letter, the number of times it occurs, factorial. Now, if there was a second letter, let's say there were 2 A's as well in this word, I would have an additional 2 factorial to represent the 2 A's. And that's how you would deal with that. Okay. So this example, you want to add this to your notes as well. How many distinct ways can the letters in the word lollipop be arranged? So again, we're going to first figure out how many letters are in the word. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 factorial. And we're going to divide that by, I see 3 L's, so 3 factorial. I see 2 O's, so 2 factorial. and I see two p's, so 2 factorial. So 8 represents the total, 8 factorial divided by 3 factorial for the 3 L's, 2 factorial for the 2 O's, and 2 factorial for the 2 P's. And so that gives me 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. The 3 times 2 times 1 is gone. And I just have 2 times 1 times 2 times 1. So let's take a moment, type that in, and figure out what we get here. 8 times 7 times 6 times 5 times 4. And we're dividing that by 4, which is 1,680. So there's 1,680 distinct ways of arranging the letters in the word lollipop. Okay, so that takes care of the lesson for today. I'd like you to work on pages 6 and 7, and then pages 8 through the top of 11. You'll see where the problem ends for that page at the very top of 11. So 6 and 7 and 8 through the top of 11 is your assignment.